Hello again. Here we are looking at our notes on arithmetic sequences. So I have a couple examples here of an arithmetic sequence. So a sequence is just a set of numbers that follows a pattern. And so here we have 2, 4, 6, 8, 10. We have 5, 1, -3, -7, -11. These two sequences are arithmetic. These are sequences. They do follow a pattern. So -2, -4, -8, -16, -32, 1, 4, 9, 16, 25, but they do not follow an arithmetic pattern. So the key here, look, is +2, +2, +2, +2, -4, -4, -4, -4. So if we either go up or down by the same number every time, that is arithmetic, and that number is called the common difference. So the common difference here is 2. The common difference here is -4. So these ones follow a pattern, but it's not adding or subtracting. So this one was just times 2, times 2, times 2, times 2. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So any sequence is a set of numbers that follows a pattern, but arithmetic has to have a common difference where we either increase or decrease by the same amount. Okay, we use a special type of function notation for arithmetic sequences and geometric sequences and any other sequence. Instead of f of x, we use a sub n. So a sub n, the n tells you what term you're on. So 2 would be a sub 1, the first term. 4 would be a sub 2, the second term. 6 would be a sub 3, the third term. Okay, so it just tells you what term you're on. So the n is like the x. The a sub n is like the f of x or y. Okay, so recursive is the fact that as long as you know this number, you can find the next number. So if I know the common difference is 2, if this is 10, I know the next number is 12. Well, if the next number is 12, then I can add 2 and get to 14. And then I can add 2 and get to 16. So this is the recursive formula where it says take the previous number and add the common difference, whatever that common difference is. Recursive formulas are nice if you have numbers and you're just trying to find the first 5 numbers, the first 10 numbers, but it's not very helpful if you need the 50th number or the 1,000th number or even maybe the 10 millionth number, because then you would sit here and have to keep adding 2 until you get out to the 10 millionth number, so that wouldn't be very helpful. So we also have what's called the non-recursive formula. Okay, so a sub n is still the same. That's like our y or our f of x. A sub 1, like I said, is the first term. So this is a sub 1 for this sequence. This is a sub 1 for this sequence. Okay. Plus, well, each time you add the common difference. So plus d times, well, how many times did we add it? Well, for the second term, we only added it once. For the third term, we added it twice. For the fourth term, we added it 3 times. So you're actually adding it n minus 1 times. So that's the formula we use, but we don't leave it in that form. We distribute the d and combine like terms, and we write it in the form a sub n equals c plus dn. Now this formula, I can plug in any value for n and find that term. If I want the 100th term, I just plug in a sub 100 and plug in the number 100. So I can plug in any number I want if it's in the non-recursive formula. All right, so example 1. For each problem, find the recursive formula, the explicit formula, that's the non-recursive formula, the explicit formula, and use the explicit formula to find the 10th term. So here's our sequence. 7, 3, -1, -5. So the common difference is -4. So the recursive formula, we keep everything except that where the d is, we just plug in the number. So a sub n equals a sub n minus 1 minus 4. And I say sub because these are subscripts. They are not full size. Like an exponent is a superscript. These are subscripts. They go down below. So this is a sub, The minus 4 is not a subscript. It is a regular number. All right, so the explicit formula. Well, we have to start with this a sub 1 plus d times n minus 1. So I have a sub n equals, the first term is 7, minus 4, because that's the common difference, times n minus 1. So then I distributed the negative 4, so I got 7 minus 4n plus 4. Then I combined like terms and got 11 minus 4n. So that is the explicit formula. A sub n equals 11 minus 4n. So then to find the 10th term, well, that's like saying plug in 10 for x. But in this case, we're saying plug in 10 for n. So a sub 10 equals 11 minus 4 times 10. 11 minus 40 is negative 29. All right, so example 1b. I have negative 4, 5, 14, 23. So each time I'm adding 9, so positive 9 is the common difference. So the recursive formula, again, everything stays the same except that we just plug in d. So a sub n equals a sub n minus 1 plus 9. The explicit formula, well, we have to, again, start with the a sub 1 plus d times n minus 1. So I get a sub n equals negative 4, the first term, plus 9 times n minus 1, because 9 was the common difference. So then I distribute the 9, so negative 4 plus 9n minus 9. Then I combine like terms, negative 13 plus 9n. So that's the explicit formula. A sub n equals negative 13 plus 9n. Then we have the 10th term. So a sub 10, not a sub n, a sub 10 equals negative 13 plus 9 times 10. So negative 13 plus 90 is 77. All right. And of course, we always want to be able to apply things to actual real life. And, these aren't the most realistic problems, but we try. The higher up in math you go, the more realistic most of the problems tend to get. All right, so example 2, find the recursive formula and the explicit formula for how much money you have in the savings account after n months. So your grandparents give you $100 to start a savings account. Each month, you add $50 of babysitting money to the account. So you're starting with $100, so that would be a sub 1. Each month after that, you add $50, so that would be d, your common difference. So for the recursive formula, all you care about is the d. A sub n equals a sub n minus 1 plus d. So you just plug in the 50 for d. The explicit formula, you need both the a1 and the d. So a sub n equals a1 plus d times n minus 1. So then I distribute the 50, so 100 plus 50n minus 50. Combine like terms, and a sub n equals 50 plus 50n. And that's the end of our arithmetic sequences.